Okay, thank you. Yeah, and thank everyone for attending. Yeah, my name is Juan Gutierrez. I live in Managua, Nicaragua. I'm a software developer and just a big fan of spatial data, maps, and all this were related to geo things. And the topic I'll be talking about is geocoding for non-standard addresses. A little bit different than the title of the event. But yeah, let's start by trying to define what non-standard addresses are. So we have an example on the left side of what I call the standard addresses. As I think probably most of you can relate to them. Is easily recognizable. And have very good support for geocoding providers. Almost any geocoding provider will resolve this type of addresses. And then we have on the right an example of what I call non-standard addresses. In some sources, non-standard addresses, or more likely non-standardized addresses, are just those which have a little bit different, probably order or something not right in the right place for an address. But what I call non-standard is are addresses that are different nomenclature entirely, as we can see there in the example. Believe it or not, that is actually an address we use, and that actually is a place, and we now can find coordinates. This is a very common address that we make fun of because it references a little tree. So yeah, and those addresses until now they are not supported by the big geocoding providers. So the goal of this development is provide such a service. So yeah, let me try to explain very quickly how we can make sense of this addresses we use here in Nicaragua. And it is better if you think about them as indication or shortened indication of a treasure map, actually. And so yeah, we can see there a little tree represented there. This is actually just a reference that can be any other type of place. This concept is more related to a point of interest, that is called on OpenStreetMap. And yeah, so we have there. So the indication is from the little tree, go 1 block to where the lake is. Yeah, if you can see at the top of the screen, there's a little blue there that represents the Managua Lake. And yeah, it's one of orientation that we use. It is most of the time is referred to the north. And then we have the second instruction is walk of drive 25. This is BRS is the shortened for Baras. Is a unit of measurement, roughly the same as yardsticks. And the orientation we got is up, and we can and that up is actually referred to where the sun goes up. Is the translation of arriba that we use in Spanish. On the contrary, we have down or abajo, and that refers to where the sun goes down, or where the sun sets. So yeah, when where the sun goes up is just the east. That's the same on every city in Nicaragua, and west is the down orientation. So yeah, I think within a few days of staying on Nicaragua, you will probably get used to this type of addresses. It's not that difficult to understand for humans, but yeah, the goal of this system is to let the computers actually understand these addresses as well. So what we did first is analyze all of the addresses, trying to find some patterns in them. So we came up with some heuristics for these addresses, some entities that are recognizable and are also present in most of these addresses. For example, here is a very the same address we saw before, but a very basic example where we have just three entities: reference, segment of displacement, that in short is segment, and then the city. But there are also many more. I actually wrote a paper last year that is also available there if you can, or if you want to understand the other entities that can be found. Um, but yeah, this is the very basic one. And we have to do this because there were not anything, any research, any investigation, any academic paper or research regarding these addresses. So we have to go learning and understanding on the way on their own. So yeah, so then we face the challenge of how we ask an user all of these entities. In the very beginning of the project, we had a form with several inputs, but we found that very difficult for some users, like a barrier that will prevent them to use the system. So we developed our own machine learning model that will take the full address and will then extract the entities from the address. It's just an implementation of the naming entity recognition part of the machine learning. And yeah, this is based on spacing. And we found that actually all previous models that have the name entity recognition are not performing the best for this kind of domain. So we kind of started from scratch with a blank model, and yeah, this allows us um, to let the user type the addresses just like the way they use it in everyday. So yeah, when now that we have the entities that will allow us to get the coordinates, how do we get to those coordinates? So yeah, the algorithm is actually kind of very straightforward. We find the references, the coordinates of the reference, like we saw in the example. In that case will be the coordinates of the little tree. And from that little tree, we apply all of those segments of displacement. And there can be many of them, from 1 to 5, probably 5 would be a lot of. But yeah, there's actually not a limit there. And we just repeat that the steps are as necessary. Yeah, so the algorithm is actually straightforward, but then in the details is the difficulty. For example, regarding the references, something we use in Nicaragua specifically is some reference that doesn't exist anymore, or references very like that little tree. So these type of references are not very suitable for how our databases of places like the one in Google Maps or the one in OpenStreetMap. So we have to create our own database of references that will allow to track those references that, for example, doesn't exist anymore. And then we have other challenges. For example, if you can see the grid of the streets are not exactly aligned to the north or to the east. Also, the blocks are not exactly 100 meters each of those blocks. So yeah, we have this challenge of going for an approximate way to find the coordinates, or rather a precision way to find it. And in my case, specifically, I had little experience with OpenStreetMap. So I went to what I know, which is Google Maps. And by using Google Maps, the best that we can do is just an approximation, because we don't have the exact, for example, the exact nodes that makes on a street. And also we cannot know the inclination of the street. Like I said, the streets are not exactly um, uh, let's say, for example, 0 degrees to the north are uh, not exactly aligned, right? So yeah, so what we have implemented right now is just an approximation that sorry, that uses the Google Maps APIs, and we kind of use some clever use of the Google Maps that, for example, will allow me to calculate the orientation of the street, and the results are always snapped to a row, so that way I avoid to have coordinates in the middle of nothing.
Yay!
And yeah, in the future is the use of OpenStreetMap, leveraging all of the information there, the nodes, the ways, the places that will allow to not have some assumptions like I mentioned about probably not being exactly 100 meters.
Yay! Yay!
In the very near future, I will hope to start working with OpenStreetMap data. So yeah, at the moment, this is an example of what we have right now, where the people can type the addresses in Nicaragua, and the result will be a coordinate. We estimate the current precision is about 80 meters to where it's supposed to be. And yeah, I have to mention that this development is not meant to keep these addresses forever. It's just we want it to be a bridge to a new format that will be similar to the standard address.
Hi everyone. Sorry, I don't know what's happening. A lot of people are swarming into the room, and this is obviously there. Can you unmute one?
Can you hear me?
Yes, we can hear you now. Sorry about that.
Sorry. Okay, no problem.
Sorry about that.
Yeah, no problem. Yeah, why are not calling this development geocoding for Nicaraguan addresses? Because I think this approach can be used for other countries that use similar addresses. An example is Costa Rica. We are neighbors to Costa Rica, so we share many things, many cultural things, and one of them is similar addresses. As you can see in the example here, yeah, to me, it's very similar to ours. And actually, the same model that we developed for getting the entities right now without any further training can recognize up to 60% of references and 90% of segments. And yeah, also there are other instances where addresses are not like the standard one, but are more similar to this descriptive addresses, like the one used in Puerto Rico. It's difficult to find addresses that use this in official sources, but I understand that they are very commonly used in Puerto Rico as well. And also I have heard in other countries like Mexico, Colombia, and Chile that use similar addresses as well. So yeah, I think in the future, this same approach can be used for those other countries with addresses, with non-standard addresses. And yeah, thank you for attending. This development is available in this website, and yeah, any help is welcome. Probably this development will not scale up to many other countries, so it's difficult to find any sort of funding. But if you know any, for example, cooperation for countries that can help us to reach more precision or further improvement of the tool, any help is welcome. Or otherwise you can share our development on Twitter or anything else. That's also welcome.
Thanks very much, Juan.
Yeah, thank you so much.
Thank you. Stephen, any questions?
Yeah, I've got a couple of questions for you, Juan. Mark Tobias asked, yeah, and he was joking, but he said, what happens when the little tree becomes a big tree or no longer exists?
Yeah,
I sort of had a similar question, which is when you're using these sort of popular references, what happens when there are several of them? I mean, can you tell the difference between a little tree in one part of the city to a little tree in another part of the city?
Yeah, it's funny because actually I think right now there's no tree at all in that place.
Right.
But yeah, to a few years ago, there was a tree that actually was a big tree, but the reference stood in the cultural or the popular knowledge, and the very same place is actually called right now the little tree, and it is indistinguishable or let's say, sorry, unique from others in the city. Okay. Anytime you hear about the little tree, is that very same position, and that's why sometimes established database of places are not the best probably source for this, because what you said, sometimes the current places change of name or doesn't exist anymore.
Yeah.
And similarly, for distinguish same names of places, the addresses used to have the neighbor, and within the neighbor, we can find relatively easy the place they are referring to.
Okay, and I think you also touched on this one, but I was wondering, the images, the map images you're showing are sort of nice square grid cities.
Yeah.
What happens when the streets go off at different angles or there are curved streets?
Yeah, exactly. That's one thing I mentioned, that right now, because my previous knowledge was only through Google Maps and using their APIs, I can only provide an approximation.
Okay.
Yeah, and when the streets are not straight, so the approximation, of course, will be beyond the average. And that's one thing we want to improve by using OpenStreetMap.
Great.